taco, 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 taco. Stop! Sorry, we're gonna have to talk about loops. Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter. Welcome to Terraform Tuesdays. Today's topic is all about using loops to access complex data structures in Terraform. And this is actually based off of a viewer comment that I got a while ago, a question that I didn't really have the answer for. And then they figured it out and sent me example files, which is amazing. And so this entire video was inspired by their question and what they came up with as an answer. And so I would just want to reach out and thank John Akiraman. I think that's how you say his name, John Akiraman. I want to thank you for putting this together and letting me do this video all about loops and complex data structures. It's pretty cool. Before we get into the nitty-gritty details, I just want to quickly mention that my Terraform certification guide is available on LeanPub. So if you're thinking about getting the Terraform Associate certification, go ahead and check it out. The link is, of course, down in the description. All right, let's get down to brass tacks. What are we talking about here? Well, the initial question was basically saying, listen, I get a data structure from somebody else, and I need to interpret that data structure in a Terraform file to create a bunch of virtual machines in Azure, and with different numbers of disks attached to them and different virtual networks and subnets being attached to each one, potentially multiple NICs on each one. So I need to be able to interpret what's in that data structure and apply it to my Terraform configuration. And the data structure I'm getting in is going to be JSON. I need to be able to interpret that and iterate through it to create all these different resources. And I was like, wow, that is complex. I didn't have the time to tease it apart when he asked. So he went out and figured it out himself, which is awesome, highly encouraged. And I want to share the process that he went through. And we're going to do this by using for loops in Terraform to iterate through multiple instances of a particular resource. In this case, we're talking about multiple virtual machines, but it really could be anything, multiple virtual networks or multiple databases, whatever you need to create a bunch of. If somebody's giving you the data structure to do that, you might not have control over that. And let me just give a concrete example that I know exists out there. You might have a ticketing system where people put in a request, and the request generates a form that they have to fill out. And within that form, they designate how many virtual machines, what the specs are for those virtual machines, etc. And that might spit out a JSON doc, which then you have to ingest into your Terraform operations to actually deploy that infrastructure somewhere. So you don't have control over what's in that form or how it's structured, but you need to, smash it into your existing Terraform modules to make use of it. So that's the utility of this particular application. So let's pick apart what's going on with the for loops and what the whole intro was about with nested loops. So let me just show you a quick diagram. All right, let's say that you have multiple virtual machines that you have to create. So what you're going to have to do in your creation process is actually loop through each of those virtual machines and interpret the data inside each one of those virtual machines. Now, each one of those virtual machines, if I represent that with an orange rectangle here, that's one virtual machine, it might have multiple disks. And you're going to have to loop through each of those disks. So we have one loop that's going through each of the virtual machines, and then a nested loop inside that that's going through each disk. And you might have to do the same thing if you had multiple NICs on that virtual machine as well. Loop through each of the entries for the virtual NIC and configure it to be attached to the proper subnet and with the proper IP addressing scheme. So that's just to give you a foundational idea of what we're going for here. Let's go over to Visual Studio Code and take a look at this in practice. Here we are in Visual Studio Code, and just a quick reminder, these files are always available on my GitHub. I have a repository, Terraform Tuesday. A link should be popping up down there right about now. And if you need to follow along or just want to refer to this later, you can always go to that repo and get the latest version. We're looking at a folder that is dated for 2021-01-25, and we're looking at the simple JSON format. So this is just representative key data that this is representative JSON data that we can parse through. Now, if you're not familiar with JSON, this is going to get very confusing. So, definitely go watch a video or a tutorial about JSON before you watch this, because otherwise you're going to feel a little bit lost. But basically, JSON always starts out with these curly braces, and then it's a key value system. And the key is going to have a value of some kind. That value could be a string. That value could be a list. That value could be a map. And a map is just additional key value pairs. In fact, you can have a map inside a map. And inside that map, you can have a list. You can see how this can get complicated pretty quickly. Now, how does Terraform go about parsing through this structure? Let's take a look at the accompanying main.tf file that I have for navigating this simple JSON data structure. Yes, I know there's no root module. This is the simple main.tf, and I'm not creating any resources here. I am simply defining some local values so that I can look at what those values are using Terraform console. In order to load all of our data into the JSON, we can use the JSON decode function, and we can pass it the file using the file function. By doing that, we will load the JSON into a local variable, but that's the whole thing. If we don't want to load the whole thing, we can actually refer to a specific key within that JSON by doing the JSON decode dot whatever that key is. In this case, we might be referring to list 1 in our example JSON data. Let's open that up and take a look at what that is. List 1 is a list of 3 items, so we'd be referring to that list 1. Alternatively, we can take our existing all JSON data local value and refer to a key within that and load that into its own local value. So map1 data, that's what we're doing there. So let's go ahead and open up the commands file that I have, and we can walk through a little bit of how we actually manipulate this data once we have it. All right, so I've already run Terraform in it. Let's go into Terraform console. Terraform console will interpret expressions that you give it as if they were inside the configuration, and it loads the values that you have in the configuration so you can manipulate them, which is why you have to run Terraform init before you run Terraform console on a configuration. I've already run Terraform init, so now we have access to all of our local values inside that configuration. Let's take an example here. We know that we have local all JSON data, so let's go ahead and copy that, and we're gonna go ahead and run it down below. And if I scroll this up a little bit, there we go. We can see it gives us all of the information that's in our config.json file, and it knows that it's JSON, so it knows how to interpret that. Now, we also extracted a list from that. So let's do local.list1_data, and that shows us just list 1. And remember, we also grabbed the map data. So let's go ahead and run that. And there we go. We can see we've got our map data. Now, how do we refer to an individual list element inside our JSON data? Well, we could do that by doing the square brackets and the 0 to refer to the first element in our list. If we do that, we should get the value list 1. There we go, list 1. If we want to refer to a map element, we can do that by the key. We know that there's map key 1, 2, and 3 in our map. So if we do .map key 1, it should give us the value that corresponds to that key, map value 1. Now that we have a basic understanding of how to work with JSON in the context of Terraform, what about looping in Terraform? What if we have multiple values that we want to loop through, like I just talked about? We can use the for syntax. And before we dive into these examples, I think I need to explain a little bit about how the for syntax works. Here's an example of the for syntax. Let's parse out what's in here to understand what we're trying to do. The square bracket at the beginning and the end before you have the for keyword basically says, I want you to return a list object to me when all of your work is done. So whatever you're doing in this for loop, I want the value that you give back to me to be a list type. If it was curly braces, it would give you back a map type. Okay, so that's what type of data should be returned. Now, what data are we loading into our for loop that we want to process? Well, that goes after the in keyword. And in this case, we're pointing at local.listData. So we're assuming we have some list of data that resides in this local value that we want to iterate through in a for loop. How are we going to refer to each element in that list? Well, that's this first keyword after for. List_items is how I can refer to each element as I go through the loop. And then finally, after the colon, we tell it what elements in the data type are returned. How do I want to construct the list that you're going to be giving me at the end? What are the elements to include in that? Now that's an example of using a list to create a new list. You can also load map data into the for loop and still have it output a list. So the data type that you use as input does not have to match the data type that it spits out as output. Let's take a look at creating a map output instead of a list output. So you'll notice that for the data type returned, we're now using curly braces, and that says, I want to map it back out of this. I don't want a list. The data source we're using is in the same position. After in, you tell it, where am I getting this data that you want me to use? And then you have to supply two values here to refer to the values inside your map. The first value will be the key. It doesn't have to be key. You can name this whatever you want, but that first value will be the key in the map. And the second value will be the value that corresponds to that key. So key comma value is a good way of doing it, but you can really name them whatever you want. Then you have to tell it what elements are going to be returned. And because we're returning a map, we have to have a key for that map and a value for that map as it iterates through the loop. That is how you would construct a map using a for loop. And just like we saw before with the list type, you can actually load a list in as the input data source, and as the output, you can have a map as long as you can construct new values based off of that list data. So that's a little primer on for loops. I hope that makes sense. It's going to make more sense in a moment as we go back to Visual Studio Code. All right, now that we have a good understanding of how for loops work, let's construct a list from a for loop. We're going to be using the local.alljsondata.list1 as our data source. So we're putting a list in, and the elements we will refer to using the character I. And then the output is going to be a list, and the list that we're going to construct is simply the same elements. So I'm just putting I in there. So the input is basically going to match the output here. So if I go ahead and run this for loop down below, we'll get a list of 3 elements because that's what was in the list. How about if we wanted to transpose the keys and values in a map? We could do that with a for loop. The for loop I'm highlighting now, we're getting the data from local.map1_data. So we're loading in map1. For the key, we're using the letter K. And for the values, we're using the letter V. And you see for the output, we're using the value as the key, and we're setting the key as the value. So we're transposing the two. Let's go ahead and run this for loop now. All right, we got map value equals map key 1. Okay, so we transposed the values. That's one thing that you could do. Now, something that I didn't show in the slide was that you can also put an if statement after you define what the contents of your list or map are going to be. That if statement can control what's actually going into those elements. So let's say I wanted to get a list for only tacos. Let's take a look at my config_data.json. And if we scroll down here, we've got list 3. And we can see inside list 3 are 3 maps. Inside each map, we have a value, and then we have food is taco or food is pizza. Let's say I only want the food ones. I can do that within the constraints of my list. So I am creating a list using a for loop. I'm using I again to identify the element we're going to iterate with. I'm referring to list 3 as my input data, and I'm going to print out I, which is a map object, but only if I.food equals taco. So it should skip the pizza entry in my list of maps. Let's go ahead and run that now. All right, so you can see the output includes list 3 subkey 1 and 2, which are both taco, but not subkey 3 because that was pizza. So that's a basic example of how you can use for loops in Terraform to iterate over JSON from an external data source. Now let's take a look at a less contrived example with a data structure that I created. Okay, we're back in Visual Studio Code. I'm going to go ahead and open up the config data.json file that I have in the complex JSON directory. And this is meant to define more of a full environment. Maybe you've got some storage accounts. You've got some virtual machines you want to define. You might have one or more different types of virtual machines. So in this case, I'm pretending that I'm creating a Kubernetes cluster. So I might have my K8s master virtual machines, and then scrolling down, I might have my K8s worker machines. Scrolling down some more, I might also have a Bastion host that I want to deploy that gives me access to this Kubernetes cluster once it's created. So those are all my virtual machines. And then I also might want to define one or more virtual networks for my virtual machines to live on. And the virtual network is going to have an address space and one or more subnets that have different priorities that'll correspond to how I'm doing the address space division. So that's a good example of how you might have a data structure that has nested lists inside of it. Now, based off of this data structure, let's take a look at what's going on in our network.tf file. In our locals value, we are loading the JSON data using the JSON decode function from the file that's in the same directory, and we're specifically interested in the virtual networks. So we have .virtual networks at the end to load the data that's in that key. If we go back to that key and scroll up, we see we have virtual networks, and then we have multiple keys inside that for each virtual network that we want to refer to. We've got a K8s-VNet, we've got a W-K8s-VNet, and then we have a third network called Hub VNet. And in my mind, the Hub VNet is not something that we're creating, it's something that we're connecting to using a peering connection. So we don't want to include that in the virtual networks we're creating. Let's go back to that network.tf file. Now, the next part is a little confusing. I'm talking about network subnets here, so I want to get a full list of all the subnets I need to create. And within that information, I need the virtual network where I'm going to create that subnet, the name of the subnet, and the CIDR block I want to use for that subnet. I need all of that information, but I don't have that in the data structure I've been handed as a simple list item. Instead, I've got these nested subnet entries that have a name and a priority, but they don't have any address information, and they don't have the name of the VNet directly in it. So I need to compress a bunch of data together. Now, before I try to pick apart this entire command, because it's a little bit confusing, let's instead take this one step at a time by going over to a visual representation of the information I'm trying to pull. What you're seeing here is actually fairly complex, and it was very confusing the first time I saw something similar. So instead of trying to attack this head on, let's break it apart into its component pieces by opening up commands.sh, and we're just going to walk through this together. So first, let's get into Terraform console. Okay, now that we've launched Terraform console, let's start exploring things using a for loop and our network key. So we're going to be outputting a list. So we've got our square brackets, and we're doing the network key is the keyword for the key in our map, and then network, and we're loading in our VNet JSON data. And we're only loading in the network keys if the network key is not equal to hub-VNet. Remember, we don't want hub-VNet. That's just something we're going to peer to. So let's go ahead and run this command here and just kind of see what the output is. All right, cool. We can see that we got a list of our 2 VNets that we're actually interested in creating. Now let's explore that structure a little bit more. And instead of returning the network key as a list, let's see if we can get a list of the subnets in our networks. I'm going to go ahead and run this command below. All right, cool. If we scroll up here, great. I got my subnets, but I can't tell which subnets are part of which VNet because that's not included in that information. I just see I've got master, worker, bastion, master, worker, bastion. That's not very helpful to me. But we at least got the subnets we want. So what can we do next? Well, let's start with just an inner loop of a subnet list of one of the entries, the K8s-VNet. So if we refer to that directly, we can see here's our 3 subnets. And let's see if we can just extract the subnet name value out of this subnet list. So we're going to do for subnet. We're looking at the list of subnets in local.vnet.json_data.kates-vnet.subnets. So this is the subnets that are inside that kates-vnet. Just give me a list of the subnet names. Can I pull that out? Let's go ahead and run that. Awesome. Now I've got the subnet names. Now, what if I wanted to create a map of those subnet names and return a list of maps? Let's try that. So instead of just giving subnet name at the end of my for loop, I've now changed it to return a list of maps where the key is name and the value is the name of the subnet. Let's go ahead and run that and see what happens. Boom. All right. I've got a list of subnets with name equals whatever that subnet name is. We're getting closer. We're building something here that we can actually use. All right, let's try adding a CIDR address calculation. So this is getting even more complicated, but stay with me. We can do this together. Now we are still returning a list of maps. The second item in that list of maps is going to be CIDR address as the key, and then we're going to use the CIDR subnet function, and I'm going to pass it the address space of the VNet that I know directly. We'll figure out how we refer to it later, but I know that it's 10.12.00/16, then the number of bits I want to add to the mask, and then which network with that new mask I want. And I can use the priority number from the subnet to get that. So let's go ahead and run this big, long command. I know they're getting bigger and bigger, but it has to be all one line when you're dealing with the Terraform console. So if we run that, all right, now we're getting somewhere. Now I've got a list of maps, and each of those includes the CIDR address that I want calculated and the name of the subnet. Awesome. We are getting places, people. This is great. Now, what I really need to do is do a nested loop starting with the network. And this gets even more confusing. So before we look at this, let's bounce over to a slide where I can kind of show you what's going on here. All right, so we know that we have two networks, our kates-vnet and our w-kates-vnet. And I'm going to set kates-vnet, I'm going to use that as the network key, and then the network data will be the value network. I know I can get at the subnets by referring to network.subnet, and I know I can get to the address space for this VNet by doing network.address space. So this is what I know. Now, within this, I want to get the list of subnets and associate it with that virtual network and with that address space. So I'm going to, on my first loop through the outer loop, I'm going to pull the information for kates-vnet, and I'm going to have an inner loop where I loop through each subnet inside kates-vnet, and I set it up with a network name, a subnet name, and I'm going to use the subnet priority to calculate that address. So the network key that you'll see is going to be kates-vnet because that's coming from the outer loop into the inner loop. Subnet.name I can use because I'm going to use the keyword subnet inside my inner loop, and subnet priority I can get to by referring to subnet.priority in my inner loop. And then we'll run a second loop, and that's going to be for the w-kates-vnet, and we'll output separate information for that. Okay, so that is what we're doing in a more visual representation. Let's go back to Visual Studio Code. Okay, so here's my first loop. I'm doing a for loop, and I'm getting network key and network from local.vnet JSON data. So this is the entire virtual network's data structure. That's a map. And I'm identifying the map key and the map value, network key and network. And then we're going into an inner loop here. And in that inner loop, I'm going to do for subnet. Where am I getting this subnet value for? I'm getting it from the outer loop value network.subnets. Awesome. So this is my list of subnets. I want to generate a map that has within it the subnet name. So that's what I'm doing. Name equals subnet name. I want the CIDR address space for this subnet. So we've already figured out how to calculate that. And then lastly, I want the name of the VNet itself, which is equal to the network key from my outer loop. And once again, we only want the networks that do not equal hub-vnet. That's a lot of information in one line. But if we go ahead and run that whole dang thing, we're going to get a list here. But if we look at the top of this list, we actually have a list inside a list. Because of the way that it iterated, we actually ended up generating nested lists. Now, we don't want that, but we're definitely cooking with gas. We got all the information that we want. So the very last thing we're going to do is we're going to use the flatten function to flatten out the list items into one flat list instead of a nested list structure, which is what we have right now. And that'll make it easier to iterate within Terraform. So it's the same command that we had before. I just added flatten to the end. And if we go ahead and run that and scroll down, whew, there we go. Now we're starting with just a list, and it's a list of map items that is every subnet that we want to deal with within our configuration. And we can apply this again and again to any sort of nested structures that we're dealing with within Terraform. Now, I leave it as a project to you to fill out the actual network information here to deploy those VNets and subnets. And maybe if you're feeling frisky, you could even develop the necessary configuration for the VMs, or I might take that as my own project. But hopefully I've shed some light here on how for loops work, how you can take complex data structures, ingest them into Terraform, and then manipulate them in such a way that you can load them into a Terraform module that you have to create VMs or create VNets and get the necessary output that you want, which is properly deployed infrastructure that matches what was in that requested data source to begin with. So I know that was a lot to take in. I hope you followed along. Maybe you need to watch it again. I totally understand. This was tough for me. I'm not going to lie. Like the first time I looked at all this code, I was like, say what now? What is going on? But if we go back and take a look at the finished code here for network subnets, we have almost exactly what we just saw, but it's way more readable because now it doesn't all have to be on the same line because of the whole Terraform console thing. So now you'll see we're using flatten. We're looping through our network, our virtual networks with the network key and network. And then we're doing a nested loop of the subnets, and we're getting our VNet name, our subnet name, and the CIDR block for the subnet. And that's being stored in network subnets, which we can use as a local value in our configuration. All right, that's all I have for today. Thank you so much for watching. Hey, if you're looking for a way to support what I'm doing around here, I got a few ways you could do that. Number one, if you want, I have a Patreon available. The link is down in the description. If you want to sign up for that, it starts at $2 and goes up to, I believe, $15 if you're going for the big burrito. You could also subscribe to my podcast, Day 2 Cloud. There's a link down in the description as well. And finally, you could just subscribe to the channel. I've made it over 1,000 subscribers, but hey, more is better, right? That's, like I said, that's all I have for today. Thank you so much for watching. Stay healthy, stay safe out there. Bye for now. Hey, you remembered to wear the right shirt today. True, yeah, it only took me 3 weeks. I guess my work here is done. I'm famished. Time to go get some grub. Yeah? What are you gonna get? Oh, I think we both know the answer to that question.